Hello. Today we will continue our experiments with previously explained tricks and tips and how we can live without let and without macroses. And today's stream will be it quite serviced because it will explain how we can overcome some corner cases we will met with implementation of macroses into runtime approach. Let's explain it a little bit deeper. So now we are trying to live without macroses, without closure macro system, and trying to emulate the closure macroses in runtime, so create so-called our own bare bones runtime macroses. Yep. And first of all, we are trying to emulate a previously created let macro via lambda, and we create a regular function, a regular lambda object, called it lambda let. It has its arguments and it returns body, which should be evaluated via eval form. So let evaluate it here, and first of all let's look how it expands without evaluation. It expands in a nested in place lambdas, which will call on some arguments. Yep, and then if we'll evaluate the result, of course it's 6, a1, b increment 1 is 2, c increment b is 3, 1 plus 2 plus 3 is 6, and it's okay. And I can repeat the some terms of usage, some call conventions. We have to call lambda let with quoted arguments of bindings and quoted form for evaluation. That's why there are quote symbols here, and that's why eval, external eval there. But let's implement such type of function. If we have to create some function with formal arguments a and b, and inside of it we will use our special form let. We will create two new bindings, c and d, based on input arguments based on a, b, and previously created argument c, and then we'll return the sum of all that bindings. Let's evaluate it here. Well, we have let, everything's fine. Function f returns result 21 on arguments 2 and 3. You can check it and everything's fine. But if we decided to hide let, then we can't. Oh, maybe not this way, maybe this way. Yeah, let's eval. Warning let already exists. Yeah. Here syntax error, because now let is not our special form. Let is now 42 and we have no let. And we still try to use our lambda let, just created above, in approach of implementation of function f. Yeah, we directly substitute previous let with lambda let, add a quotation symbols here, and add an extra eval. And we can evaluate this function. First of all, I'll try to show you how it will macro expands, so-called. Yes, again, nested functions on some arguments, and then evaluation of this form in this context. But trying to evaluate this f, oops, we have syntax error and so on and so forth. And now for all of you who are interested in what's the matter, what's the reason of that issue, of that error, you can stop the video and trying to find the reason, and what is more important, trying to find a way how we can overcome it, how we can overcome this issue and this error. So, let's decide you stopped once, but for all the others, let us continue. The reason is that eval form, closure core eval form, special form, evaluates in not local bindings of entry of function f, but in current namespace, but in empty local bindings surround. That's why eval form cannot have access to the values of arguments A and B. But here we rely on them. In my own list called listscript, eval behaves a different way, and it has an access to everything in current local context, and there was not such type of issues in my language, but Clojure has such type of issues, and we therefore have to do something, have to do the tricks to overcome the situation. Let's try first. First of all, we see here a quoted vector of bindings. Maybe we can do these things, exclude quota from the vector itself and add it to the symbols D, C and D, but exclude from the symbols A and B. Maybe keep on C here, yep. Let's check. Again, the error is so it can't get a value of symbol C. For example, if instead of C here there was just a number 2, then it seems that everything... Oh no, again symbol A is not... So anyway, that's not a way. But what the way is actual one? I'll try to introduce you another thing. So here in the place of bindings we have binded symbols and actual values, but we can construct it in such type of things. First of all, we can catch the actual values of form parameters A and B of wrapped function, yeah, and then bind the internal symbol A and symbol B with actual values of symbol A and B coming from the function call. And then below we can rely of just binded symbol A and use it here, and just binded symbol B and use it there. So that's a simple trick. We combine 4 bindings, internal A, B, C, D instead of C, D only. But it works. Let me show you. First of all, how it expands. Oh, we cannot expand because it have to have the value of symbol A. But instead of expansion, yes, it works, and result is the same, 21. So actually, what takes place here? The eval form evaluates the big form with nested bindings of internal symbol A with actual values. Here we call function f with a value of A2 and value of B3. And here would be the vector bind symbol A to value of 2 and bind symbol B to value of 3. So maybe we can say that we will rebind the income symbol of function f and rebind it inside of internal expression that will be evalved by eval function, but it seems like it's only the way how we can overcome the eval function to put all the values inside of internal form we should evaluate. So that's the little trick how we can use the lambda let, and therefore it's a nice example, and now we are living without a let and without a matrices, and emulate the behavior of matrices via so-called lambda expressions and explicit eval forms. And in the next nail we will use it for finally solving our previous task: can customer have an order, is order allowed or not, and implement this approach inside our cond let. It will be not macro but actually a function. So see you on the next nail.